Alright, so this video is going to be about solving or manipulating formulas. So manipulating formulas to solve for a specific variable. It's also called in your textbook, um, oops, sorry. It's called in the textbook, so under 3.1, solve for specified variable. So that's what we're going to be doing, is solving for the specified variable. So when we say we're solving for a specified variable, we're talking about things like this. Um, we're talking about this. So let's look at this one right here. This one's really, really interesting. This one, for example, the 5m minus 7. All right, equals r. Okay, so in this equation we have two variables. So we have to look out for the 5m and for the r. Now that means that we are solving for m. Now we can treat it just like this. R is just any number. M is just any number. The object is to get M by itself. So we're going to do the same process as we would use to get X by itself. We're going to first multiply each side by 3 to get that thing off the bottom. And if you don't know what I'm doing here, watch the basic algebra video and it'll help you out. This crosses out with that, and we're left with 5m minus 7 equals 3r. So that's the change. And instead of multiplying, if this was any number over here, if this was, say, 6, we could multiply 3 by 6 and get 18. But we don't know what r is, so we have to leave r as a variable. And so what we're doing is just leaving it in there and putting all the processes around it. Now from here we add 7. And now we have 5m equals 3r plus 7. So again, we're just adding it around the variable. And now we have this, finally, this 5. But it's impossible to divide 3r plus 7 by 5 until we know what r is. The only way to do that is to just write it like this, as we have in the beginning. And if it looks familiar, it's because it is. It's the opposite processes that produce m. So we just use the opposite processes, the same numbers, reorganized in a different way to solve for m. So now if we're going to be looking at our math textbook here, this right here is now solved for m. But what if we don't have numbers? What if we got something like this? It just says, like, let's do this one. Let's do number 32. So here's something like number 32. Why would we ever need to solve for that? Like, why would they make us look at this and say, well, I want that h? Well, sometimes you know an area and you know a radius, but you don't know a height. And so that becomes difficult. So if we say area equals 2 pi rh. Now, another way to look at this is its area equals 2 times pi times r times h. So we could say, oh, well, that kind of looks familiar. I know how to undo multiplication. What undoes multiplication? Division. So what we do is we take this and we divide by what we don't want. We don't want this, and we don't want this, and we don't want this. This is the same as saying 2 times pi times r. Now we could do each of them individually, but if we do them as a whole, it works a lot better. Because this 2 cancels out with that 2, this pi cancels out with that pi, and this r cancels with this r, making this h, since we have to do both to both sides, right, equals a, or area, over 2 pi r. Now let's discuss that. So since we don't know what 2 pi r is, because we don't know what r is, or a, we can't divide a by it because we don't know. So it's left to just being a variable. So if we happen to know a and we happen to know r, we can find h. We just plug them into our formula here, and now we have a formula for h instead of a. We started out with a formula for A, and now we ended with a formula for H. I'm going to do one more of these, and it'll kind of help you understand where I'm going with this. So, this right here, we're going to do number 35. So, V equals 1/3 pi r squared over H. So, V equals 1/3 pi r squared over H. Now this one's a little different because we have that 1/3. That 1/3 is a different number. It's not 2. If it was 2, we could just divide like we did before. But 1/3, in order to reduce that, that's like saying this is all multiplied, right? I'm going to make that r. And this is multiplied to this. So if we're saying all that's multiplied, then that means that 3 is divided, right? So we can write it like this. Which means that we have to do something before we can divide. Since the 3 is on bottom, we have to multiply. So, real quick, these things are equivalent. These things right here, this right here, and this right here are equivalent. They equal the same thing. If you were to do all the math, plug in the numbers, they equal the same thing. What I did is I just took this 3 and put it over everything because it's multiplication. And when you multiply, technically these are all over 1. And you multiply straight across. So remember your rules for fractions. You multiply straight across. So those end up on top and the 3 ends up on bottom. That's how that came there. Now we do this. Those cross out, but we're left with a 3v over there. Like, oh, that's cool. We don't know what v is, so we can't determine what that number is. But on this side, we're left with pi r squared. Now the squared we don't really care about because it's attached to the r. So it doesn't really mean anything. It only means things when I know my r, but I don't know my r. So I'm just going to keep it there. Now I'm going to divide by pi over r squared. Why? Why am I going to do that? Well, we're solving for h, right? So if we go back to this, we're solving for h. It wants h again. Just like in this equation, it wanted h. But we had an extra step because we had that pesky 3 that we had to remove. So we divide both sides by this again. And now our h equals that. Because these crossed out, right? So we get h equals 3v over pi r squared. So this is how you manipulate equations without the numbers. They're the same as equations with numbers. We just leave the variables alone because we don't know what they mean. I call this math without numbers, but you'll hear it called either manipulation of formulas or solving for specified variables. Now, I want you to try a couple of these and let me know if you have any questions. But the biggest thing to remember, when you're solving for specified variables, you need to make sure you know what you're looking for. So make sure you know what one you're looking for and then use your processes that you would use on regular numbers to reverse it. Now there's one more thing that I should talk about, simplification versus solving. So solving is when we have an equal sign. So a problem like this. 4 plus x equals 6. That's solving. So when we do it this way, this means that we're going to be solving for x because this equal sign right here. That says solve. But if you have an equation that looks like this, this is a simplify. So simplify, right? There's no equal sign. Okay, so you're going to just do 4, and you're going to distribute, and your answer will be 4x plus 24. There's nothing else we can do to that equation unless we had an equal sign. If we had an equal sign, then we could solve for x. But we don't have an equal sign. The only time you can solve for x, so this is done when we're simplifying. This is done when this is what we would solve for. So we would then solve and we would get x equals 2, and that would be done. but only when we have an equal sign. So when it says simplify, always remember you're always going to leave it in a form that looks like this. Like this. All right, that should answer any. Let me know of any questions you have. I'm going to make a couple more videos for 3.2, but this should cover sections in 3.1. Answer any questions. If you need more help, I can do another video on these sections or help you when we meet face to face on Adobe Connect or whatnot. All right, that's the video.